Hello and welcome to the IWCS Expo poster presentation. Our objective was to create a multiplexed wiring power distribution module to be used in pairing with the Eaton E33 switch modules. These modules can be used in automotive applications to make wiring simpler and enhance user experience. The circuit features a buck converter for input voltage regulation, 3 high-side drivers for output, a 3.3 CAN transceiver for converting CAN messages to 3-volt logic, and a SAM E51 processor for simplified programming. The project uses a bootloader from the UF2 bootloader family. This allows the code to be written in Arduino. Arduino was chosen for its simplicity and its user-friendly interface. To protect the PCB, the design of a case has been 3D printed out of ABS plastic for the ease of manufacturability and quick testing. The ABS filament has high tensile strength, thus creating a rugged prototype. Lastly, a gasket lines the bottom of the top portion of the case to create a sealed filament. Creating the board was a rigorous process. We went through multiple iterations, each improving on the last one's shortcomings. While some of the improvements came in the form of selecting smaller parts, others came in the form of rearranging the board for easier fuse access. The code had 3 major milestones. The first milestone was toggling an LED on the Feather M4 CAN Express board. The next was lighting up the LEDs on the E33 switch face. The final milestone allowed the individual switches to be set to one of the 3 drivers. The case features an internal rib structure to help mitigate forces applied to it. Screw holes were designed in each corner at the top and bottom portion of the case so that the top can be fastened down to the bottom portion of the case. Lastly, mounting flanges allows the whole module to be mounted in various places to the vehicle. When it came to testing our implementation of theory, we tested the circuit functionality to ensure everything was in well operating order. The codes were tested with the Feather M4 and later with the PCB to ensure functionality. Finally, the case for the prototype was combined with the PCB to check proper fitment. Our final prototype featured an operational PCB, a functioning code, and a protective case that fit well around the board. We tested the PCB by supplying power to it and checking the pins, and the code functionality showed success by compiling within Arduino. In the future, we hope to incorporate low-side drivers and Bluetooth capabilities, clean up the code to make it easier for the consumer to understand, and use machined aluminum for more practical production and usage. This concludes our presentation. Thank you for listening.